Yeah, I mean, I am looking forward for this presentation. We're going to be hearing from Dan, and he is going to be giving us a good amount of information from start to finish of small-scale residential projects. And I am hoping that we can all get a good path that we can follow when we're working on projects or if we're thinking of doing our own home. So with that, I'll just pass it on to Sarah so she can give us more info about Dan.
Hello, everybody. Welcome in today. It is so fun to see where you all are calling in from. Thanks for letting us know. If you haven't already, throw something in the chat, let us know. And with that, I would love to bring you all into kind of a poll. It's a little informational poll for us in the chat, not necessarily something that'll pop up, but just let us know what your role is, what your profession is. That'll help us and also our speaker today, Dan, just kind of know who you are and what you're doing, what you're interested in. Take a couple minutes to go ahead and do that, and I will introduce Dan. Dan Whitmore is a longtime denizen, or as I was so excited to say today, denizen of Seattle, Washington, here in the United States. Dan Whitmore is a CPHC and a CPHB, and is the founding member of a development group called the Red Door Sustainable Housing. And he's in the throes of relaunching his construction company, Blackbird Builders. In an effort to evolve building practice, he combines passion for the politics of energy, sustainability, and social justice with over 35 years of residential construction experience. It's awesome. 15 years ago, he discovered a passive house methodology rather, and has endeavored to make a standard practice for his and others' work since then. Self-identifying as passive obsessive, which I love, and I'm totally going to steal that, Dan. Dan has built, or at least consulted on, dozens of projects ranging from 500 to 50,000 square feet, and is also following at 12 years as being an instructor and a curriculum developer for FIAS, Builder and Trades programs. He's also shared his knowledge and experience with over 1,500 trainees. So that's amazing. Lastly, he serves on the board of FIAS and on Passive House Northwest and is a constant advocate for advances in building practice. And in his spare time, he also likes to go on adventuring on roads and trails, but commonly ends up watching cat videos on the sofa, which, yes, same Dan. With that, thank you guys for populating some stuff in the chat. Please continue on to do so as it comes to you, and I will give it on to Dan.
All right. Thank you, Sarah. Thank you, Jose. Thank you, everybody at Accelerator. Great to be here. Great to see everybody. We got a nice full room here. Wow, 103. That's great. Thank you, everybody from all over. Hi, Julie. Good to see you. So I'm off in this other corner of the U.S. So great to see folks from all over the world here. I'm going to go ahead and share my screen and take you through my process. So I've had the opportunity to do a lot of projects. I've really focused on it. I don't get to do it exclusively. Very commonly, as probably a lot of you have experienced, everybody is excited by it, and then by the time the rubber hits the road on the projects, the one I'm working on right now, sadly, is just code level. It's a letdown. But you know what? We came in with the charge to do it the way we want to do it. So really for the folks out there who want to make this happen, I'm going to go into sort of just the 101. So Zach asked me to do a 101 of like, okay, what's just my general process in getting projects from concept to fruition. So it's a big difference from what it was 15 years ago. Lots of things have changed, lots of things have evolved. I personally don't do many small single family anymore, except I'm maybe building one right next door to me here in the near future. I'm focused more on the sort of low-rise, mid-rise residential. So the example I'll be showing a lot of pictures of is a 12-unit apartment building. But so who am I? I've been in the construction world since the 80s, coming up from the carpentry wearing tool belt. Now I'm a developer. I was indoctrinated at an early age, though, back in Oklahoma, in the plains of the U.S. My parents built one of those Jimmy Carter era energy efficient homes, so I got to operate that in my teens and see what could happen. And so then when I moved into the construction world, I've been really focused on making better buildings, just standard practice. So lots of projects. The one in the lower right is the one I just completed a year ago. It's got good occupancy. Full occupancy is running quite well. The one on the lower left is one that I finished with, I helped finish off for Cascade Built. That's a 104 unit apartment building in Seattle. So lots of projects, various scales, lots, 35 plus projects, but only 24 were design certified, 18 have been fully certified. But I'm moving off over 250,000 square feet of finished product. So pretty exciting. So what's my process? Just quickly, I don't know, do we have any results of who are here, what professionals are here? I'm not tracking the chat. Anybody?
We've got a few architects in here, several people
Mhm.
who are pursuing their certifications. It looks like also a mixture of interest personally and professionally.
All right. Okay, cool. So
Energy.
mostly designers in the crowd, a good healthy number of designers, which is great. I largely speak to the builder crowd. So a lot of my information here is going to be coming from builder crowd, which is really important for the designers in the group to understand, because to get your projects to actually fly in the end, you're going to need to be able to speak to the builders, because they're the ones who are going to take your concepts and turn it into a three-dimensional reality. So just a few points we'll be going through about that. So diving in, first thing you got to do, you got to select your site. Where are you building? That's going to define so many components, right? So what community you're, and so what your location is going to tell you what kind of trades you're going to use, what kind of materials you're going to use, the comparable construction costs. That's one of the first things everyone wants to know. I was just teaching in Austin, Texas. There's a very different price point in rural Texas than in urban Texas, but there's a very, very, very different price point, even from urban Texas to urban Washington state. So tremendously different things. And then when we go out the open market, we start pricing windows from various manufacturers. The cost, the cost percentage of all those components are going to vary greatly in terms of whether your budgets can afford them. Michael, I know you're there in New York City. You got a big construction budget. So that a lot of these things we were talking about, which add additional costs, are going to be a very small percentage. For some of you, they're going to be a huge percentage for others. So construction costs are going to be very critical as you piece your project together on the front end. You're also, location is going to define your passive building community. So with that, you're going to be able to see, okay, who can I turn to locally to find the good trades, the good suppliers? So if if you don't have that community around you, look for it here on the accelerator, but also look to engender it as you move your project forward, because there's likely people in your community who want to do this as well. So create those working groups. And then lastly, the thing for your location is the authorities having jurisdiction. So your building inspectors, your planners, work with them. So some of you, I've got professional contacts downtown who will help me guide through my permitting process here. Some of my building inspectors that come out on site have built passive buildings. So it's I've got a tremendously supportive AHJ community here. So you're going to have to define that for yourself. So that's where your site, when you choose your location. But really importantly, your site, when you go to your site, it's going to define the passive components. We're looking at my next potential site here. We've just got this under contract, 7,500 square foot lot. We're going to build another 12 or 13 apartment building on it. So look at that site. What do I immediately see on it? Well, what's my climate? I'll Seattle, Washington. I know that one. But what's my building form? That building form is defined by the property. Some of you have the liberty to modulate your building form at will. Me, when I build an infill, my building form is going to be defined by the land, by the property I'm able to acquire. So, and then my ground connection, what are you able to do? This building is going to be an apartment building replacing that single family home. It's going to be built into that hillside. My ground connections we need to find. And then last, my solar exposure. Those 60-foot tall fir trees in the background, those are staying. 100%. We're keeping those trees. My solar exposure here is pretty minimal. Well, It's Seattle, Washington. That solar exposure is pretty minimal anyway. So it's got a really nice eastern exposure, nice light, so I can accentuate that. Not a lot of exposure to the south with that big building. So when you are looking at either acquiring the land to build on, or you are looking at the existing land, it's really going to define how you work with the passive components of on the building. Hey, and Sarah, if people are asking questions, or Jose, if people are asking questions, please go ahead and fire them off right away. I like the questions during the flow of the presentations. So, all right. But then after you look at the site and work on that, we get to decide what we're going to build. All right. And that's again in your court. That's going to define what's the building program. Is it a single family? Right. Once you look at that, then you're going to be able to really analyze, like my multifamily buildings, even this little small 10,000 square foot multifamily building, you don't need to do a lot of work on the enclosure outside of good windows and air tightness. So your program of largely is, if you have a building with very poor internal gains relative to the building, you're going to need to work a lot harder on that enclosure. Right? And so the small residential is really going to emphasize a lot more fundamental design and engineering, energy engineering on that front end. When you're looking at the small residential, you're going to have to work harder because your internal gains are low, but also your building form is likely not particularly great. Right? In order to serve that 2,000 square foot building, you've got a lot of exterior on to communicate with the entire exterior world. So with that, your building form, you're really going to have to accentuate. This is a picture here of Skylar Swinford's house. Many of you have seen Skylar's, and even though it's tremendously beautiful, and but they were very effective at really simplifying the form of the building to minimize that exterior enclosure. So also, many of you are looking at really needing to cost optimize your projects. We are building a better building. You're going to need to put additional resources into that building, time, material costs, better products and individual material. So these products are better than your standard construction. So it's going to take a little bit more. What Zach and I cut our teeth in the passive world working on very high dollar single family residences. Budgets were still a concern, but there was a lot more leeway to do to invest in the additional work required to build a better building. But currently, in the past number of years, I've been working on projects where the budgets are very constrained. So that's very much going to define a lot of your decisions as you go through. So you got to set your expectations early, right? And you got to design the building to meet that budgetary constraint. But do play around, have fun. This should be a really exciting moment to dive in on your early project, on your passive projects on the front end. So look at those forms, look at those building forms, augment the skins of the building nicely, change the exterior look, but don't necessarily modulate the actual critical components, but do stay in your sandbox. A lot of projects that just as they're going through design, all you architects out there, how many projects got, the creativity doesn't get the best of us, but we appreciate it and our clients appreciate it. And then we start designing things that we can't actually afford in the end. So we need to walk that back. So stay in your sandbox. Then this design process, I really, really, really encourage everybody to understand who's going to build it. So ideally, that person or entity, they're going to inform what we do. Right? If you choose to use, say, insulated concrete forms on your building, that's going to define a lot of the architecture. And if you use timber, stick frame buildings, we can be quite a bit freer with how we modulate our building because the material component of the structure itself lends itself more readily to thermal bridge reduced augmentation of the enclosure. So really, ideally, you're going to find who's going to build a building early on. Okay? You don't have to, and plenty of projects don't have that leeway, but plenty of projects also shift gears and find somebody else to build it after the first that first design had somebody else in mind. But it's a best case scenario. You team up with that person early. So as from Sarah's introduction, I work with FIAS a lot. I know a lot of folks here are not working with FIAS projects or FIAS certification protocol. I'm on the FIAS board. I'm vice president of the FIAS board. I've been part of the FIAS for ages. Most of my examples, pretty much all my built examples, use their program. So if you're looking for somebody, look to your passive networks, because there's lots of professionals out there, especially from the builder side. Look to who's done this work before to at least help inform what you're going to do. So, and then the certified databases, both with Accelerator as well as FIAS, you can look to examples in your region. I find that to be a really great resource for when people ask me, what should I do? What should I build? I say, well, what have other people done near you? All right. How are we doing, Sarah? Any questions?
We have two questions, actually. Great timing for a little pause. And I am going to invite the folks who have asked their questions in the chat. Looks like Aaron and Chris to maybe Aaron first and then Chris, not at the same time, to unmute and ask your questions. And if not, I'm happy to read them off for you.
Yeah, sure. Happy to jump in. Thanks so much. Terrific
Great.
presentation so far, Dan. I'm a developer in the New York City, and I'm working on a passive house. Running into a lot of challenges from a cost standpoint. I'm, as you can imagine, I'm wondering how much you estimate additional cost price per square foot for the passive component. If you can kind of break that down, if you have any sense of it, how do you think about that in relation to your underwriting for the projects that you're building?
Are you doing infill, like row houses and that sort of thing?
I mean, I'm doing a couple of different things, but yes, and the passive is a single family house.
Right. But well, basically, I always like to do a cost as a percentage, because I was just in Texas and people said they can build a new house for $120 a square foot. We can't even touch the material costs out in Seattle, Washington for that.
Yeah, yeah. I mean, I've talked to people that are building for less than that in other markets.
Yeah. So I always like to look at it as a percentage. I also like the phrase my co-teacher and good pal Adam Cohen used to say, what's a bag of groceries cost? It depends on what goes in the bag. Right. So how much more does it cost to fill a bag, a passive bag of groceries? Well, it depends on what you put in the bag. In my projects, I shoot for a 5% to 3 to 5% additional cost. So that's what I'm striving for. It's a better building. I am able to optimize. If you're doing a row house, you don't have to insulate to your neighbors either side. You need to do the front, the back, and the ceiling, and the ground.
That's it though, 3 to 5%, and that includes the additional cost for labor as well.
Yep.
Okay.
But but as I've done, dozens of projects. My friend and business partner, Sloan Ritchie, he's doing, the 104 unit building. He was able to get in for less than 5%. You look at Massachusetts, the multifamilies, I'll say this, the multifamilies are easier on a certain regard because we're doing a lot of additional work. And the lot of the passive work is on enclosure, making a better enclosure, right? And so with a single family house, now your enclosure is more of the bucket. And so you're going to probably need,
higher.
It'll be higher.
5 to 10, maybe.
I would look to, ask Michael Ingwe in here. He's here. He does this all the time in New York City. You know, you already have expensive labor, so a little bit more of that expensive labor, you know, and the goal is to keep it in that 10%, 5 to 10% probably. On your first project, it might go 10 to 15, especially if you get extra creative. So that's the stay in your sandbox line. That's specifically speaking to that. So we need to be aware of what our budgets can allow, and then we design the building. We conceptualize the building to that budget. So if you have a budget, get your team to develop the project to that budget. And it's a strict budget. If you know you have an additional funds available, if things get extra creative, then you can be a little more playful.
Great, thanks.
Sure.
Awesome. Really robust question and answer. I'm going to have Chris, if you would like to hop off mute and ask your question, and then we're going to save some of these for a little farther down the line, just so we can make sure the presentation's on track.
Yeah, hi, can you hear me?
We can.
Great. I'm trying to flesh out an idea of taking loads off grid for a grid connected house in retrofit and being able to avoid a service upgrade from 100 to 200 amps. So I'm trying to think of ways to maybe connect just enough solar panels to feed a heat pump water heater, you know, maybe EV charger and stuff like that. Do you have any examples of where that's maybe working or not?
Sure. The building behind us, we were limited to 600 amp 208 phase, 208 on the pole. And so we actually worked, that's one of the reasons why the budget, we were able to keep it within that budget line item. It's because we designed an energy efficient building. And if the building itself, okay, those loads that you're putting on, I'm not sure where you're located, Chris, but if you're those peak winter loads on the grid, if we can really modulate them down with not needing much oomph out of the heating system by building a better enclosure for that peak heat load, that's great. You've dropped that load down. If you can then also simultaneously back up, so we're storing energy thermally with a better enclosure, but then we can also back up our electric loads with some kind of battery to get through those peaks, as well as run the ventilation systems, run all of the things, the hot water system you're going to need to do in your house, regardless of the season. So the battery can provide electricity backup for the thermal backup that the building will provide. Make sure you have a very efficient equipment throughout the building. You should be able to get most things under that 100 amp service. All right, I'm going to dive back in, Sarah.
Yes, please.
Okay, and stop me again when there's some more good questions like this. All right, so ideally find out, because who is going to build it is going to help you define what you built. So what's it going to take? All right, what's it going to take from an enclosure standpoint? For those who haven't used it before, the PHA prescriptive calculator is a great starting point. All right, this was developed so that you can it can start with an initial definition of how well your enclosure is going to work. So Aaron said he's in New York City, so we go to New York, and we're going to New York City. We'll go by JFK. We'll say it's a 2,000 square foot single family house. You got 4 bedrooms. All right, you're going to build a 3-story, right? And then we end up with, we have an envelope area, and we end up with our initial thermal enclosure considerations. All right, we're saying that our walls and overhanging floors need to be R37, our roof 68, etc. This is a very specific initial snapshot, though. And my job as a consultant is to hone this practice, because the prescriptive methodology for PHA is a worst case scenario. So your worst performing building in the performance base, where you actually do the full energy model, is going to perform better than this one. Right? So this is our starting point for where we the sort of worst case scenario of what we need in our enclosure components. So also the other way to look at what it's going to take. So there's your link for that snapshot if you want. Is to look at your other buildings nearby, see what your neighbors have needed. Okay. And then we can start defining how well our enclosure needs to work. So look at the snapshot from FIAS, the prescriptive snapshot, and then think like, okay, I'm going to do better than that. I'm going to energy engineer my building, and we're going to look at more in alignment with what my colleagues have been delivering already. So with that, then we know what we want to build with. We know the components that are going to need to go around the building. Then we get to start designing with our kit of parts. So step 3 is designing the building. And 3.1, make sure you stay within your budget. Okay. Because we want to get these buildings built. It's not just an effort of conceptual investigation. My personal priorities, I generally like to keep my buildings on the ground because the thermal buffer of the ground. I optimize my glazing. I really use efficient windows. We've got really good options for our windows here, but I also optimize the form of the windows, you know, and so I'm minimizing, I'm shooting for that 15% window to wall ratio, ideally, all right? We want to make sure I'm designing in plenty of room for the ventilation, both where the ventilator goes and the ducting, the distribution for it. Really working on the good building form. So I want my all 6 sides of the box. And if you are on a strict budget, this is first and foremost the way you can design your building to stay within a budget. Minimize your projections, overhangs, and corners. Every one of those turns and twists in your building is going to be a energy budget. It is also going to be a tricky point. It's really easy to do the fields of your building when you're constructing it, but it's really tough to make those interfaces function well. And then we get nerdy. So run an energy model early. Design that building, okay? Test your assembly R values. Don't decide on the materials quite yet. Just say, I think I need an R23 wall. Put it in there as an R23 wall, irregardless of what you're making it with. We just want to know what the R factor is of our components. I really like to play with the dial of our window performance, but I also the assumptions for all these things, because then we can go start and ask our teams what we want to build with. So good notes. It's really easy with the software now to do case 1, case 2, case 3, case 4, and just try out various permutations of our window performance, our wall performance, our roof performance. It's a little harder on them to adjust the geometry of the building, but it's really easy on the models to adjust how well the individual either opaque assemblies work or the windows work. So it's good to dial in your design, the shape of the building, the look of the building, without having to adjust the geometry. So with this, then we can hit our goalposts. And once we've hit our goalposts, here's my starting assumptions, just quickly. I want a really good ventilators. First and foremost, I make sure I put good ventilators in my building. I want a triple glazed window, center glass, at least 0.17 or better. Those are the opaque assemblies I'm starting with. And then my FIAS air tightness limit, I set it at the maximum. Okay. And then I kind of define my building with those effective considerations. Okay. And then just go ahead and submit it for design certification. Have a professional look over your model at this early stage, okay? Run that first case. They are the experts in this realm. Utilize, but don't abuse their expertise. It's not their job to design your building, okay? But they will definitely give you really good input, feedback on what's being done. All right. And then after we know what we're going to build, or while they're working on that analysis and reviewing your design, then finalize your team. So we're passing it off to them. We're doing that design component, and then we're starting to choose the team that's actually going to do the thing. So line up that builder, line up your rater or verifier. They're usually very experienced in helping you guide you to the finished goal of achieving what we're intending. Make sure your structural engineer is involved. Really important to have a good structural engineer on these buildings, because a structural engineer who doesn't care about thermal bridging is going to kneecap your project. So make sure we have a good structural engineer and also have a good mechanical designer. So those that we need all of those are the four outside of the designer. These are the four critical seats I want on my project. And then with that team and with the initial feedback coming back from our certification review team, we get to know what we need to build with, and we can start doing those assemblies. Right. So we're going to finalize all our assemblies at this stage, after we have our teams together, after we know what the goalposts are. All four control layers: thermal control, air control, vapor control, and water control, bulk water control. We need all four control layers, all on all sides of the building. How are we going to do it? And then we're going to start detailing our connections. We're going to do comprehensive air barrier documentation. We need to know how this building is going to be assembled. So many projects are like, okay, I know what I'm going to use for my air barrier in the center of the wall, because that's the easy one. We need documentation of how we're doing the difficult ones. We also need full ventilation design here. The sticky wicket on most of my projects, honestly, getting to final certification is getting the ventilation systems to work. We know how to do an airtight building. The ventilation systems are still one of the toughest ones. And partially it's because we're not doing as comprehensive a ventilation design as we ideally would have. So here's an example of an air barrier document that I like my team to develop. And we're going through, and the red line that we draw around our building turns into multicolored pencils. And now I know who's going to be doing what and when, with what. And I have options. Oh, is the building wet? Is the building dry? Is there snow on the roof? Like, we need options because our buildings can't wait for the optimal weather that we need to keep rolling. So creating a separate, not a part of the plan submittal, not even a part of what we send into our design certification team. This is the construction team. So create an air barrier document and think through all of the challenging locations. Don't worry about the simple, easy field ones. Think about the challenging ones and design them in. Okay, because that's going to define literally sometimes how our structure goes together. We are going to be able to need to go back to our structural engineers and say to them, you know, I can't build that because it's not going to work with what you want and what my continuous air barrier requires. All right. And then while we're developing all those documents, we've got our design certification. I strongly recommend those of you who are doing your first or early projects, make sure you've got design certification in hand before you start your project. Okay, I don't always do that anymore because I'm experienced in this. You don't have to, but if you want to get certification in the end, it's really important to make sure what you intend to build can be certified. Okay. There are some levers we can pull late in the game, but some of them we just can't. So make sure you understand your program. Make sure you're working with your third-party rater who's going to be out in site, and make sure you've got that letter that says if you build it to these documents, you will be able to be certified. All right. Just in a quick example, this is the final certification, design certification on the apartment building, small residential apartment building behind me. You notice, look at that bottom left corner, the envelope area ratio. 1.5. How awesome is that? You're not going to get that number in your small residential buildings. You're going to be up at 2.5, 3. And that's the area of the box in relation to your floor area, your usable floor area. That is one of the biggest dials we can design our buildings to efficient performance with. I also, when we're at this stage, at least on the initial projects, always want to identify the critical component that's going to be the closest, and it's going to limit my certifiability. So I'm within 10% on the heating load in this project. Great. Now as I select things, as those windows come into too expensive, and I need to value engineer down to a lower performing window, I can know that I've got a little bit of playroom in there. Okay. Experienced teams will take that gap down to 2%, 3%, maybe even 0.5%, because every that that closest limit is the most, meeting that closest limit is going to be the most expensive considerations on our building. Then we get to build it. All right. So then we get there on site. We know what we're building. We know what we're building with. We know who's putting the sticks and bricks together. So I just want to start in the ground, go to the walls, go to the roof, and then we'll get into our mechanical systems, and then we'll be done. So foundations, there are going to be thermal bridges. And it's one of my pet peeves in the passive community. Thermal bridge free, no thermal bridges. No, there are thermal bridges everywhere in our buildings. It's just the easiest way for energy to leave. We do pay very close attention to make sure they are not damaging thermal bridges, that we're not going to get condensation, that we're not going to get very detrimental comfort concerns from the thermal bridges. And when we're attaching our buildings to the earth, there are going to be thermal bridges. We just need to mitigate it. So most of my foundations, it's just concrete and steel touching the earth. We're then isolating those interior conditions to mitigate against those thermal conditions, those thermal bridges. So it's mitigated thermal bridges, right? So here we are doing those interior point loads. So we've got a continuous insulation below the slab, whereas the exterior stem wall was uninsulated. One of the challenges a lot of our industry has is we want better insulation underneath our slabs than most concrete installers have ever done before in their life, even if they've been doing it for decades. So it's a quality control that's required in a trade group that isn't used to it. And then you move into air tightness below the slab. Very few people have done that. So you're likely going to be needing to turn to a specialty trade to actually do the air tightness. And the problem with doing an air tightness below a slab is if it's not perfect, good luck fixing it. So you can only visually inspect it. There's very limited possibilities to actually test that air tightness down there. There are possibilities. Those of you who work in radon or methane or with contaminated soils, those industries know how to test a sub-slab air barrier. All right, here's our air barrier going in on the top of our comprehensive insulation. It's bonded to the stem wall. The stem wall makes the transition. Right, so we're transitioning to solid concrete as a really thick, robust air barrier, and then we're going vertical. In that other picture, that perimeter was our thermally broken stem wall is in that foam around the perimeter. Okay. So then we're going vertical. Once we make that foundation to wall, just my personal preference is shifting to the exterior of my structural sheathing. Many of you will be choosing that. Some of you will be choosing interior air barriers. I find those difficult to protect, so I like to put my air barriers out there personally. But choose it, install it, and defend it. And this is one of the roughest things, especially on a ventilated roof application, making a jump from exterior sheathing to the underside of your roof structure. That's one of the roughest things. In this application, we used the membrane to make that jump, protected the membrane with a sacrificial strip of plywood, and then transitioned to the underside of the ceiling. This is a fire-rated ceiling, so it's a double-layer drywall. Yes, I was very concerned with a comprehensive air barrier at that location, but we managed it, quality controlled it, so we succeeded. And we topped out the building. Ventilation, getting into our mechanicals, oversight is essential. It is one of the, we're going, in the US at least, we're going from very poorly installed ventilation systems. Bath fans, negative exhaust fans, and trickle vents and windows is a silly way to do ventilation, and now we're requiring top shelf. So metal ducts are really tough to get airtight. Maybe you can afford those continuous ducts, the home run ducts, but most of us can't. I also highly recommend pre-commissioning the flows in your ventilation system prior to cover. And then really understanding that these buildings are quiet after the fact, do extra work to make sure that airflow is going to be acceptable. The sound from the airflow is going to be acceptable to your occupants later. And then from a design perspective, make sure you give yourself and your teams enough room to work. Okay. I unfortunately have seen so many projects that have been compromised because we just didn't give the team enough room to do their job effectively. And these are really good professionals. They want to do their work right. So please give them the capacity to do it. And just briefly, a few minutes here, Sarah, then we'll skip over to questions. But the last step is the QA/QC and certification. So testing prior to cover, test your air barrier, make sure your insulation is viewed, test your ventilation, test it. Okay, for duct leakage, for static pressure. Okay, because you're not going to be able to adjust those after you cover it all up. And then again, I highly recommend actually testing the distribution before you cover. So here's a fun little video for those of you who go ahead and understand that this is a critical component and it has to work. And so there are some insulation methods that lend themselves to good installations, or you can make sure your installer does a darn good job so make sure you work with it. Because somebody, especially in the FIAS program, is going to come out on site and look over your shoulder and make sure you did do it right. So coordinate with your rater and verifier. Unfortunately, I know a few projects that didn't do that. They couldn't be certified in them because the rater or verifier wasn't there to see the critical component. And you can't pass the test if they don't look over your shoulder. All right, do your blower door tests. This is a 10,000 square foot building. Here's our blower door. Notice there's only one open port because our building was so darn airtight. 50 pascals of pressure at pressurization, because a lot of things, the dampers were blowing open. They're negative pressure. Here we are at less than right around 350 CFM at 45 pascals of pressure. How awesome is that? 10,000 square foot building. We can do this together as a team. Challenges, the big challenges, finding interest trades, especially in the ventilation and quality insulation installations. These are the big challenges, the great challenges. The air barrier detailing. Make sure you have somebody on your team who's going to follow you all the way through. Sourcing the windows is a big challenge. It's a lot better than it used to be. And then quality control of the air barrier, because it may have been put in perfectly, but now the subsequent trades are going to try and tear it up. So making sure you're you want to be able to visually inspect it. This is a big one too. It's the first adopter syndrome. Many of us in the PASC community have really liked to play with new things, new toys. It's a great concept, but also be aware of burdening your project by putting too many new things on it. Small challenges, making sure you're coordinating, making sure you're testing at appropriate moments, especially air leakage and ducting. I'd also like to, for a FIAS program, making sure your hot water delivery is also being tested appropriately. Sourcing specialty products, sub-slab insulation. These are the small common challenges in my project that I pay extra attention to. But for FIAS projects, your best resource, read this book. There are some parts that are dull as dirt, but skip those, right? Go through it. It's a wealth of knowledge in addition to your passive community, these presentations on Accelerator, but this is a great document that will help you through all steps of getting a certified building. And with that, there we go. Skylar took this awesome video, my project. And, we got a lot of buildings to build out there. So let's get them done. We want to make sure, Aaron, if they all cost 10 or 15% more, we're going to not get very many of them. But we want everybody to do these because they're great buildings. We got a lot of work to do. We're supposed to deliver 1 million new homes in Washington State in the next 19 years now. It's a lot of work to do, in addition to all those ones that need to be retrofitted. So let's make sure we create good teams to do good work so our industry is able to feed the demand. Okay. All right. Word salad.
Right. Thank you, Dan. That was an amazing presentation. I think you nailed it with way too many quotes that I just wrote here. And I guess we can run through them in a few, and maybe some of them are going to be answer some of the questions that we have in the chat. So right now, I would like to say, yeah, great presentation. I mean, it was a great way to explain how the process goes from beginning to end.
I am going to go ahead and start off with the questions. Ken has put up kind of a queue in the chat, so you might see your name there. And we invite you to, come off of mute, ask your question if you would like to. If not, it's totally fine. Jose and I will tag team and ask it for you. But up first, I have John Epperly. Would you like to ask your question? Are you still on the call?
Sure, thanks. I'm still here. Yeah, this is just a general question for anybody on your side with any recommendations for books, resources on passive design principles and past projects. You know, speaking for all the architects on here who like homework. And a quick shout out to Brent in the chat who gave 2 recommendations already. Thank you for that.
Books. There's, the passive details, that Alison Kwok and team did a few years ago. It's good, but it's also a little bit, I'd say, dated. Like it looked at some materials that we were using maybe 10 years ago. So one of the challenges, John, with any books is, I know my aunt worked in the publishing world. It takes 2 or 3 or 4 years from idea to conception to get it out to our hands. So I usually look for, and it's such a dynamic world here in the passive community. I look to the books for my building science, because the building science, that is a foundational component of all the work we're doing. So and I saw in the chat, like Buildings Don't Lie, or Alison Bales' book on buildings. What is it? Do buildings need to breathe, or don't? Whatever. Anyway, Alison Bales. Look up Alison Bales. But so the building science is there. That's foundational. I personally like the articles. I like the interviews. I like the presentations, because that's the dynamic thing as our process goes forward. So I don't know if anybody else has any thoughts on that.
Appreciate that. Thank you.
Thank you for that question. I'm also looking for good books to read, and I guess you can always look at details, but it's good to have some words with them, explain to you how that thought process was and how
Actually,
they
Jose,
apply
if I may,
better.
in details, I'd just like to put a quick note out there. FIAS has just launched their detailed library, and it's a brand new source. It is the initial details are looking back at historical projects, but it's a full detail library that FIAS will be offering up. You do need to be an Alliance member to get the access to all of the detail library, but there's some initial ones that are out there for the open market, and so those are going to be, as projects come in, some of those details will be added to the library and expanding the library. So
Yeah,
great.
I actually saw that email. I forgot. Thank you for reminding me. I'm going to put a star on it. Yeah. Okay, up next is Vincent Marquez.
Yeah, thanks. Vincent Marseille. Just a quick
Marseille.
question here. I actually have the answer, which is the FIAS prescriptive, spreadsheet is actually free to use for everyone. So that's great. I was wondering if there was potentially a PHA equivalent for people who are more used to that methodology. Do you know by any chance?
So it's a prescriptive path specific. It's a full certification path. And to my knowledge, the PHI hasn't developed a full certification path. I do know folks who are able to sort of do that initial work, but I don't know of anybody who has published a sort of a background document that will do that. Likely it would coordinate, though, in terms of your assembly values.
Yeah. Thank you. Thanks, Dan. Great presentation.
Okay, I have 2 questions from Chris, and that I'm going to go ahead and read to you, Dan. The first being, for Windows, have you considered vacuum insulated gas, promising R18 to 22?
That element of the early adopter, yes, I've considered it, but I don't want to adopt it until somebody else does outside of NASA. I was, many of us in the early edge, we were really excited to do sort of experimental building components. Until it's regularly manufactured, I'm now hesitant to do it. I just had 3 IGUs be broken on a building, and glass is really expensive and hard to source. And when we start getting into the more unique, glass is not hard to source, but when we get into the unique components and assemblies, where would I get vacuum insulated glass? It's going to be only manufactured in one facility in a far distant place. So for something so fragile, personally, I would be hesitant, especially to hand it over to a client.
Well, that makes sense to me. All right, follow-up question, maybe not necessarily follow-up to that, but second question from Chris. Any examples of air source heat pump installation on the roof or better in unconditioned attics?
Lots of air source heat pumps on roofs in bigger buildings where we especially where the property around the building doesn't have, we can't put the equipment next to the building. So where are you going to put it? Very common to put it on the roof of the building, especially if we're using the air source heat pump to generate hot water. Why? Because a lot of our roofs are really hot. The air is up there is really hot, and it's easy to pull energy out of hot air and put it into cold water. It's a little bit harder to use an air source heat pump to generate cool during the summer, unless you protect the reservoir of cool air in some fashion. Totally works though. Lots of things going on. Putting air source heat pumps in attics, to me, that would be a danger. Why? It's because that is a major cooling element that we would be putting inside a building enclosure, and we would be exposing the roof environment to a cooling equipment. And so we're pulling, our roofs, especially our vented roofs, need heat in most jurisdictions, in most climates, to stay dry, to stay durable. If we're adding cooling equipment in that environment, we could cool it enough that we could potentially see condensation up there. Granted, it's going to be a case-by-case viewpoint, but the last thing I'd say is one of the most expensive things on a tall building where you've got your heat pump on the top is bringing the crane in to get the unit off the roof. So if I've got a location next to the building, that's where I want my equipment, because I can bring in, because unfortunately it's going to need servicing, it's going to need replacing at some point. And I want to be able to get to it easily and not add an additional $10,000, $20,000 just to bring in equipment, just to swap it out.
Great. Thank you for that. Practicality is the name of the game, right? We're going to go with Briggs, iPad.
Hi, this is Jeff Briggs. I don't know why I'm being called iPad today, but hi, Dan. This is Jeff from Seattle, too. Had a question about your roof. I'm wondering if you considered, on the multifamily project you've been demonstrating here, whether you considered an unvented roof with a wall with assembly similar, say, to your walls, maybe with exterior insulation, and taking the air barrier over the perimeter as opposed to across the ceiling.
We certainly did. The idea of, instead of having that vented roof application, I am a huge proponent in my particular climate of roof overhangs. I think it really keeps our wall systems dry. We have a big problem, and because it's so wet and so damp and so cool so much of the year, that our wall assemblies are in danger of staying wet and developing compromising. And when I put on a rain hat, it's not a beanie. I don't put a beanie on and walk out in the rain. I want a rain hat with a rim. So I want an overhang on my building. That is a challenge, to go up and out and over and around. It is unquestionably possible, but a vented roof is fairly affordable. This one had the complication because it's 3 parallel gables, and so we had the valley in between, and that was one of the most complicated building science puzzles this building needed to solve. And we did need to bring in a closed cell spray foam to mitigate against potential condensation in that valley, those 3 long valleys. So what you're describing, Jeff, would be a good application to, and then we could just insulate above. Unfortunately, then this building we would have needed to sprinkle that attic too because of the fire protection, that big cavity up there. So add it all together. We had 3 shallow gables, and we filled them up with cellulose the carbon sink of the recycled paper product in the attic, the 3 attics of these buildings, almost accounts for the carbon in the concrete in the foundation. So there's a bunch of considerations. Yes, a hot roof would have worked on this, but we chose this other path.
Thank you. Appreciate the answer.
That was awesome. I'm gonna invite Barb. Would you like to unmute and ask your question, or would you like me to ask it for you?
Yeah, I can ask. So we've seen a couple instances where people have gone to plastic ductwork. Centrotherm is the one that's available here in Canada for ERVs and HRVs. And I just wondered if anyone had any thoughts about that to solve some of the issues with ducting HRVs.
Barbara, those the continuous home run ones, sort of, so the smaller diameter ones?
Correct. Yes.
Yeah. I would love to find one of those that is cost effective. When you're looking at, many of them are small enough to go in a 2x4 wall. And so then they can only push 15, maybe 20 CFM. And so then I need 2 or 3 or 4. So now I've got a lot of, footage on it. It is certainly controls for duct leakage. It certainly controls better for sound concerns. Were I not to need a group about yay big of spaghetti and run around my buildings, I would be more likely to use it. It would also be less costly. So I'd be thank you for that name. I'll take a look at it. I'm not sure it's available in my market. There's also I don't know. There's some of them are not rated for fire and smoke concerns that we have here in the U.S. So we do need to be careful with specifying, making sure they can be compliant with our fire and smoke codes, red codes.
Okay, and we're going to continue with Brent Watanabe. Hope I said that right.
It's pretty close. Watanabe.
Watanabe. Thank you.
I have a quick question, I think, about air barriers. And so, Dan, thank you for your detail of showing the continuous air barrier on the exterior on your sheathing. If you're blowing in like a dense pack fibrous material, and then you have Intello or something on the inside, is it a problem to have both like an Ad Hero or something on the exterior and then also Intello on the interior? And is it better to have, one or the other?
One of my concerns is always being able to afford what I'm asked to build.
Yeah.
And so I always like to think of, a balloon. How many air barriers are on a balloon? 1. But it has to be perfect. I can do a perfect air barrier essentially, right? And so I like to hit it and quit it is kind of what I tell my teams. Make sure that one is perfect.
Uh-huh.
Okay, a secondary air barrier will reduce the pressure on the primary air barrier. If you think about it, you put it, like an atrium on a building that where you enter one room, and it reduces the pressure that the primary air barrier sees, so it can sort of back it up to a certain degree. But in my mind, I want that one to be perfect, and we're able, my teams were able to essentially do that one perfectly, and then I can take that monies that would have been spent on that secondary one and put it elsewhere in the building and help pay for it. Help pay for the other. There are certain environments where it's really important to control the air at the interior, because air carries so much vapor that we have to be very careful about bringing the air movement into our assemblies. But if we think of a perfect air barrier outside of our building, there's no way for the air to get into it. So if it can't get into that wall assembly, go to the top of the wall and escape out, then the exterior air barrier has done the job of keeping that moisture laden air from inside the building getting into that assembly. So there are, however, vapor concerns if you're building buildings that with high density and a lot of people in them. They're generating a lot of moisture in vapor form, or you have a natatorium or a steam shower or something like that. Then those interior membranes can do a really good job of keeping the vapor from migrating through the assembly. But from an air leakage standpoint, personally, I like to put it on a robust, solid component, buried on the exterior of the building where my interior trades are not going to slice and dice it. And
Yeah.
so, and then I can save those pennies, dollars, thousands of dollars, and put it elsewhere.
Right. So in a single family situation, in this particular case, it's a ADU above a garage. The interior, like Intello, is not going to be beneficial there because the amount of interior vapor that you're dealing with is. I guess I'm worried about just say it's dense packed cellulose. I'm worried about moisture migration from, I don't know, showers and cooking and things like that.
The moisture that we generate with standard occupancy levels is notable, but it's able to be controlled. Where are you building, friend?
Milwaukee, so 5A.
Milwaukee. So your drying capacity is huge to the exterior for most of the year.
Yeah.
It's the air is so the absolute moisture content in the outside air, because it's so cold, there's so little moisture out there, that if you can make sure that you're not bringing enough moisture from inside to get to that exterior vapor control layer of your sheathing. So usually your sheathing is going to be the least vapor permeable. Paint, drywall, fluffy stuff, sheathing, membrane, siding.
Yeah.
And so we have to be very concerned in Milwaukee with vapor aggregating in that sheathing, and in your case, freezing. So it is very helpful to mitigate against moisture. Maybe just put it in the bathroom though, if you're worried about costs.
Yeah,
or
okay.
potentially use a drywall treatment that would do a similar fashion. So there are some paints that will be a good vapor control consideration.
Yeah.
But your air barrier should be perfect, especially above a garage, because I don't know about your garage, but my garage is full of paints and toxins and that sort of thing. And so I want to make sure that no air is going from inside that garage to the living space above.
Right on. Awesome. Thanks.
Sure. Keep the questions going. I got a few, maybe 5-10 more minutes. I got to jump off.
Yeah, I think we have one more. I think I have one more question from Luna. She or here is still on the Zoom call.
It looks like
Luna?
they can't unmute, so maybe ask it for them.
Oh, whoops, I didn't read that, sorry. Are there examples of elevated steel-tipped buildings that can still achieve Passive House certification?
Steel buildings, elevated steel buildings?
Yeah, on stilts.
Yes. Oh, on stilts. Yes. So there's a really good building, Finch Cambridge in Boston. It's one of the early multifamily buildings in Boston. And there is conditioned space below in a portion, and the access to above, the stairwell above is at ground level, but there's a parking garage. And so what they needed to do was add a pretty expensive but limited structural thermal break between the columns carrying the building and the steel frame that's supporting the floor system of the building above the parking garage. So significant attention to detail needs to be done for the supporting structure below. Granted, even steel has some R value to it. It is miserable. But if you have a 10-foot steel column, likely if you wrap that steel column, you put even if you do want to put the thermal break in the top, if you put that thermal break at the bottom, and then you wrap that steel column to above, likely you would be mitigate. There is no building that has no thermal bridges. Our buildings are riddled with them. We're just controlling for them. So yes, you can do a steel building, a supported steel building. You're just going to have to pay very close attention to how you mitigate from the transfer of the structure that's carrying that the floor above.
Great. Yeah, I mean, there's many projects that I'm guessing are going to be built that way. The other one I pointed out was one in Argentina, and this is it's a single family home that it's built right next to a river, River Tigre, and it is designed for the river to flood. So they even have a pier that goes. I mean, it's a dry pier until the river floods, and then they can come via a boat. So that's another cool project to check out. I just don't have any links right now that I could share.
Honestly, concrete columns are less conductive than steel columns. So, if we're thinking about how we're supporting it, just mitigating against those thermal bridges, let's think about the supporting structure and how we can use alternate components below.
Yeah, and I was just going to point out that one of the notes that I have, one of your quotes, is that they will have thermal bridges. Thermal bridge free doesn't mean they don't have any. And I know in the beginning of my practice, I was always stressed about it until I realized when I was working on some projects that you just have to really minimize them. There's no way to eliminate them for sure. So again, one of those things where you just learn it through doing. And just to wrap it up, I just had one quick question for you, more about just the process in the beginning. When you started working and doing Passive House, what was the trade situation and how difficult was it to get it to grow so you could get more contractors and people working proficiently, I guess, in your projects?
Well, my very first project, it was my own project. It was during the economic crash of the 2009, 2010, 2011. So I did really good. I had a lot of friends who were looking for work, and I was there on site all day. So if you have the capacity to do your own project and pay your own bills while you're doing it, it's a great way to control the labor coming on site. Since that time, there has been appreciable exposure, and there are some jurisdictions. Massachusetts has lots of trade contractors who know how to do it. I now have really good insulators. I still need to look over their shoulder because the person I know is likely the one coming out to direct the show. So that's what I want to make sure, though. I want to make sure that any trade partner who comes out, somebody on the team knows what we want. And I can then rely on that person to help communicate to the folks on site what we're doing. It's been 15 plus years now, and there's been really good expansion of attention for the enclosure trades, the air sealing and the insulation. The ventilation trades are still not more rare. Honestly, just minor plug for the builder training. That was critical, and so early on, FIAS asked me and Adam Cohen to develop it. So that's been a huge training ground for a lot of people who want to do this work. So I encourage people to get training and encourage that, it's choosing your builder. If we choose them really early on, like I talked about in the presentation, if we can get them excited about it, then they can go out and get some training. They can get exposed to it. They can go on tours of other projects. I encourage you all to endeavor to not have your project be the first project that your trades have ever seen a comprehensive air barrier on. There's lots of examples out there that people can visit and witness. And so it's not just, they're not coming completely green to the site.
Yeah, that's a great advice. And just to follow up to that, if you could give like a checklist on what to have on your schedule, on your calendar for, let's say, testing and making sure that you got everything right, because I know you had a note about the under slab air barrier, air seal, that you have to check that and take a picture and everything. And also the blower door test. And most importantly, I guess that I really didn't think about it until recently, is that you have to check the sound levels for your commissioning of the ventilation system, because it's a very quiet building in the end. So, I mean, I personally have never gotten to that side of it, but I found it interesting that you marked that up for all the commissioning side of things.
Yeah. Unfortunately, most people in our practice learn by example. So we learn by our mistakes when things don't work. So I'm very practiced now at seeing rigid metal ducting that's going to be loud. And unfortunately, it's really hard to get to fix. And I still make errors on it. So the checklists, after being able to spot an air leak, this is the best tool that we have to be able to build an airtight building. It's your eyes, being able to see the hole when somebody is buried, because most holes get buried before we can bother to test the building. So regular walkthroughs, and being able to see where the gaps, where the tape is pulled away, where the components aren't adhered together. And so regular visual inspections before anything gets covered. The checklist is just having I like to call him the air sealing specialist. I like to abbreviate. I like to put it on my hard hat because I like to walk the site because and see things during course of construction. Air tightness first and foremost. Secondarily, it would be the ventilation components. So as you said, it's easier to on your checklist have insulation, because that's a trade that comes in and installs it. Make sure it is inspected. Make sure it's comprehensive. Here in the U.S., we have what we call grade 1 insulation, and we in almost all locations we want, and the industry knows what it is. We want grade 1 installations, or rigid installations, or fluffy installations. No gaps, no compressions, those things. So we need to visually inspect it and document it. So critical components: air barrier, insulation components, ventilation components. Those to me are the 3 biggest. And having checkpoints.
Yeah, that's a good one. And as someone who has commissioned ventilation systems, I can tell you people definitely want to know about the sound, and they'll be like, it sounds funny, And if you hear something, maybe something that was, up in it's already closed off and whatnot, it's not a fun time to have to break that news. I'll say that. Anyway, folks, we're going to go ahead and round off. Thanks so much for staying a little bit later than, normal programming. And we really hope to see you next Wednesday for the Project of the Month event. We have Bryn Davidson of Lane Fab. And then also, of course, Thursday for the Reimagine Buildings 25. I really want to say be there, be square, but really be there and be a smart envelope.